The discovery of wormholes is one of the most mind-bending, otherworldly tales in the history of science. A story that stretches across the centuries, blending imagination, scientific breakthroughs, and humanity's unrelenting curiosity about the cosmos. It all begins in the shadow of the ancient pyramids, in a time when the Egyptian priests and mystics looked up at the stars and whispered of hidden pathways in the heavens. These weren't just stars, they were portals. The Egyptians spoke of stargates, magical doors that could transport the soul to another realm. Of course, this was mythology, deeply spiritual, not literal. But this idea of gateways connecting distant places beyond our reach, planted a seed in the human imagination. It was the first stirrings of an idea that would eventually challenge the very fabric of space and time. Fast forward to the 1600s, when Isaac Newton, sitting under an apple tree, or so the story goes, unraveled the laws of motion and gravity. Newton showed the world that the universe was not just a vast, empty space. It was a dynamic stage where objects danced in an eternal waltz, pulling on each other with invisible strings of gravity. His work laid the groundwork for understanding how things moved, but there was a lingering question: what if space itself wasn't empty and static? What if space could bend, warp, or even fold? It wasn't until nearly 300 years later that a young, eccentric scientist named Albert Einstein took the next giant step toward the discovery of wormholes. In 1905, Einstein shattered the world's understanding of space with his theory of special relativity, revealing that time and space weren't the fixed, unchanging entities that Newton had described. Time was elastic, it could stretch or shrink depending on your speed. But Einstein wasn't finished yet. In 1915, he unleashed his theory of general relativity, which turned space and time into a single, unified entity, what we now call space-time. Einstein realized that massive objects, like stars, planets, and even light, could warp space-time itself, creating curves and bends in the fabric of the universe. Imagine, for a moment, space-time as a rubber sheet. Place a heavy ball in the center, and the sheet sags under its weight. This was a radical departure from Newton's universe. Now, instead of space being a rigid stage, it was malleable, bendable, and alive. But here's where things get truly mind-blowing. If space-time could bend, could it fold? Could it twist into a shortcut, a tunnel that connected two distant points in the universe, allowing you to travel between them in an instant? Einstein and his colleague Nathan Rosen were the first to propose such an idea in 1935. They called it an Einstein-Rosen bridge, a theoretical wormhole that could connect two separate points in space-time. The idea was fascinating, but it also seemed too good to be true. These wormholes would be highly unstable, collapsing before anything could travel through them. So the idea of wormholes drifted into the realm of pure theory, a tantalizing possibility that might never be proven. But the human mind is a curious thing. Even as the scientific community struggled with the practicality of wormholes, the concept continued to captivate people's imaginations. In the 1960s, something extraordinary happened. Scientists like John Wheeler and Roger Penrose, building on Einstein's work, began to seriously study black holes, mysterious objects so dense that not even light could escape their grasp. And in this search for answers, they realized something strange. The equations that described black holes seemed to have a mirror image, white holes, areas of space where things could potentially emerge from, instead of being swallowed. Some physicists began to wonder, could black holes and white holes be connected by a wormhole, a bridge that joined them across the universe? But here's the kicker: while physicists were dreaming up mind-bending possibilities, science fiction had already planted the idea of wormholes in popular culture. One of the earliest fictional explorations of time travel came in 1895, when H.G. Wells wrote The Time Machine. In Wells' tale, a scientist invents a device that allows him to travel through time, moving backward and forward like a tourist visiting different eras. The machine wasn't a wormhole, but it was the first vision of a shortcut through time. Fast forward to the late 20th century, and we find ourselves in the age of blockbuster science fiction films. One such film, Interstellar, took wormholes from theoretical physics and brought them to the big screen. Directed by Christopher Nolan and scientifically guided by physicist Kip Thorne, Interstellar became one of the most accurate depictions of wormholes ever created. The film imagined a wormhole near Saturn, a cosmic shortcut that allowed astronauts to travel across the galaxy in search of a new home for humanity. The visual effects were stunning, but the real magic lay in the science behind it. Kip Thorne worked with the filmmakers to ensure the wormhole looked scientifically plausible, calculating the way light would bend around it and even predicting the creation of new scientific phenomena, such as the appearance of a supermassive black hole that had never been seen before. What made Interstellar so captivating wasn't just its visual effects, it was the way it made the science of wormholes feel real, tangible. It brought an ancient idea back into the spotlight and gave it a modern context. It made us think, what if? Today, physicists are still wrestling with the questions raised by wormholes. We know that they are mathematically possible, at least in theory, but we have yet to observe one in the wild. Could we one day build a wormhole? Could we travel through one? Some researchers believe it may be possible, but we would need something called exotic matter, a form of matter with negative energy that could hold the wormhole open, preventing it from collapsing under its own gravity. Right now, we have no way to create this exotic matter, and we don't even know if wormholes actually exist. But as we venture deeper into the study of quantum mechanics and the mysteries of black holes, we may be getting closer to discovering the truth. So, the story of wormholes is one of blending ancient mysticism with cutting-edge science. It started with the Egyptian priests gazing up at the stars, wondering if there was a path to other realms. It was nurtured by the genius of Albert Einstein, who revealed that space and time could be bent. It was brought to life by science fiction pioneers like H.G. Wells, and it reached new heights in films like Interstellar. And now, it lives on in the minds of physicists, who are pushing the limits of what we know, daring to ask, could there really be a tunnel through space and time? Could we one day walk through a wormhole and emerge on the other side, somewhere, and somewhen, far, far away? The journey to understand wormholes is just beginning, and the most exciting part is that the answers may be stranger, and more wondrous, than we could ever imagine. If you enjoyed this journey through space and time, don't forget to like, subscribe, and hit the bell for more mind-blowing explorations. Until next time, keep wondering, keep exploring.